Welcome to Sundar's lecture. This is lecture number 90, and in this lecture we are going to see some extra problems in two-port network, because solving these kind of problems will give you good exposure to solve gate questions, right? Maybe in the next lecture I'm going to solve some gate problems. So we will start with the two-port network in the gate problem. So we just try to see some more complicated problems, or maybe some very depth problems in two-port network, so that it will help us in solving the gate questions, right? So first thing, this is the given question now. So in this question, what they are asking you to find, they are asking you to find what is the value of I1 and I2, and they have given you this value. This is the two-port network, and they have given the two-port network value as what? This one. This is nothing but the Z parameter. So what is Z parameter? Z parameter will be is equal to V1, that will be is equal to 20 I1 plus 35 I2, right? 35 I2, and V2, which is equal to 35 I1 plus 50 I2. That is what they have given you. That is what they have given you here. This V1 and V2, they have just given you in the form of Z parameter, right? Now, what you can do, you can write KVL expression for this loop now. This is a single loop, and if you want to write the KVL expression for this particular loop, then what you can write? So, start from this point, this current is going in this way, so start from this point. So, I am writing KVL at loop number 1, right? First loop. So start from this point, you are going in this way. So it will be plus 20 minus 10 into I1 minus 10, because you are going in the same direction, and then it is minus V1 should be equal to 0. And you know now V1, right? So anyhow, you just bring everything to the other side. So it will be V1 plus 10 I1. This is the equation, and in this equation maybe I will write it down here itself. So what you will get, V1, you just substitute the value of V1. So 20 will be is equal to 20 I1 plus 35 I2 plus 35 I2, and then what you have, this is V1 we have written, and then plus 10 I1, right? Now this is the equation. This I1 and you can add these two now. So the expression will be now, it is 30 I1 plus 35 I2 will be is equal to what? 20. Make this as equation number 1, right? It is very simple, right? So now what you do, you just write the KVL expression. Maybe I will write here KVL at loop number 2. KVL at loop 2. See, I will go in this direction now, in this direction. So if I am going in this direction, so from minus I will travel like this. So the current is in the same direction as I am going. So it will be minus 20 I2 minus 20 I2, and then you are traveling from plus to minus. So it will be minus V2 equal to 0. Right? This is the expression for V2. V2. So I can write V2 is equal to minus 20 I2. That is the, sorry, this will be I2. And you see, I can substitute this equation V2, instead of V2 I can write this one, right? So it will be 35 I1 plus 50 I2, and if I bring this to other side, it will be plus 20 I2, which is equal to what? 0. So there is nothing, there is no constant term, because there is no voltage connected. So what you will get, so the final expression will be 35 I1, and then it will be plus 70 I2, and which is equal to 0. So this is equation number 2 now. So if you can easily solve these two expressions, and it is not necessary to solve, right? Because you have two different expressions, and these two expressions can be easily solved down. So how will you solve? Maybe if you multiply this equation with 2, it will be easy, right? So if you multiply this equation with 2 equation number 1 multiplication of 2, so what you will get? You will get 60 I1 and then plus 70 I2, and then that should be is equal to, if you multiply it with 2, it is 40. So the equation number 2 is already, it is 35 I1 then plus 70 I2, and that should be is equal to 0. And if you further put you minus these two expressions, so what you will get, it is 45 55 60, so it will be 25 I1. In this term will be cancelled out, it will be 0, and then that should be is equal to 40. So finally what you are getting, so I1 will be is equal to 40 divided by 25. So I am getting it as now 1.6 amperes. So we found what is the value of I1, and if you want to find what is the value of I2, what you can do, you can substitute in this particular expression. Maybe I will take this to other side. I will write here. So 35 into 1.6, that, and then it is plus 70 I2, which is equal to 0, and if you simplify this, what you will get, so it is 56, and that will be is equal to minus 70 I2. So I2 will be is equal to 56 divided by minus 70, right? So if you further simplify this, so it will be I2, which is equal to minus 0.8 amperes. So this is the final answer for I2. So now we have found what is I1 and what is I2 from the given network. See, try to understand one thing. You need to convert this is a parameter into equation. That's all. That is what we have seen in the previous classes. And please refer my previous classes for how to write the Z parameter for a given two-port network. With the help of those kind of things, you can easily solve these problems, right? So now I will go to the next problem. So this is problem number 2. Problem number 2. See, they have given an Z parameter here, and they have given the other things also here. They have connected 10 ohms, 20 ohms. They are saying that this is V2, this is I2, this is I1, this is V1, and we need to find the total Z parameter for this particular circuit. So how will you find total Z parameter? See, try to understand one thing. You try to write what is the expression. Maybe what is V1? You write this V1 and V2. How will you write V1 and V2? See, it is very simple because it is given as Z parameter. So V1 will be is equal to 50 I1 plus 80 I2. Right? This is V1. And if you want to write what is V2, so we know V2 will be is equal to 60 I1 and plus 70 I2. Right? We know both V1 and V2. Try to write the expression for V1 dash now. So how will you write V1 dash? Start from this point and you come to the plus. So you try to learn how to write an expression for voltage between 2 points in a electric circuit. So we have solved so many problems with the help of voltage between 2 points, and I have told you what is the procedure in my previous classes. Try to learn that. So if I want to write what is V1 dash, so if you want to write V1 dash, start from minus, come here, right? If you are coming here, so see, here also the same I1 will flow. Here also the same I1, because this is loop. This is loop. So obviously the same I1 will flow and same I2 will flow in this direction. So what will happen now? So you are going in the opposite direction. So it will be 20 I1. Then I am traveling from minus to plus. So it will be plus V1. And then the direction is again in the opposite direction of current. So it will be plus 10 I1. So now this is the equation. So what is V1 dash now? So what I can write 20 I1. Instead of V1, write this 2. So it will be plus 50 I1 plus 80 I2 plus 10 I1, right? That's all. We have written all the expressions now. So finally I can write what is V1 dash. V1 dash will be 20, 70 and then it is 80, right? So 80 I1, this 3 are completed. 80 I1 plus what? Plus 80 I2. Make this as expression number 1. That's how we have found V1 dash, right? So if you want to find what is V2 dash, so try to write V2 dash expression. So start from this point and go here and come here again, right? So if you are coming in this direction, so it will be plus 40 I2 plus 40 I2 and then it is plus V2 because you are traveling from minus to plus and it is coming in opposite direction to me. So it will be 30 I2, right? So now V2 dash can be written as 40 I1, 40 I2 plus what is V2 here? It is 60 I1, this equation, plus 70 I2 plus 30 I2, right? Then if you finally simplify this, V2 dash will be is equal to I1 is only one term that is 60 I1, 60 I1, then there are 3 different I2 terms. It will be 100, 140 plus 140 I2. Right now, this is equation number 2. And now, what they are asking you to find, what they are asking you to write, you need to write what is the Z parameter for the whole circuit, which means whole circuit holds the V1 dash and V2 dash, right? And current of I1 and I2. See, that is what we are getting here. So, what will be the final Z parameter here? So, Z parameter will be very simple. What is that? This is the first term, 80, and this is the second term, 80, and this is the third term, this one 60, and this is fourth term, that is 140. See, try to understand one thing. Now this is the Z parameter. Now this is nothing but Z11, this is nothing but Z12, and this is nothing but Z21, and this is nothing but Z22. That is what they have asked you to find. This is nothing but Z outer. Z outer. See, don't confuse yourself if you see any problems like this. These kind of things are all very simple to answer the questions if they are asking you some inner and outer. See, very simple. If you know how to convert the Z parameter into equations, then if you want to write the KVL expressions, then it will be very easy to understand, right? We will take the another one problem. Okay, fine. Now you see, we have taken another problem. See, they are asking you to find 4 different parameters, and we try to find what is the first one, second one, third one separately. Before that, we need to write any one of the equations. Either it can be y parameter or it can be z parameter, right? So because this has current I1, I2, and there are node, you can easily have nodes here. So we try to write the y parameters, right? That will be very easy to, right? So for example, you consider this as V1 and this point as V2, right? Because this is V1, right? This is V2. So it is very simple. Maybe this point is also considered as V2. Both are same, right? Because there is nothing connected here. Then obviously it will be V1 and V2, right? So if you want to write a KVL expression for this point, what it will be? So I am just writing KVL, sorry, not KVL, KCL at node V1. So what I will get now? So I1 will be is equal to, maybe this current is flowing in this way. So it will be V1 by 10 and then plus V1 minus V2 by 10, V1 minus V2 by 10. Right, this is what only 2 branches, 3 branches are connected and I have written all the branches here. So this is the I1 expression, and what I will get now? So I1 will be is equal to 0.1 V1 plus 0.1 V2 minus 0.1 V2. Sorry, this is V1. This is V1 minus 0.1 V2. So finally, what I can write here, so I1 can be written as 0.2 V1 minus 0.1 V2. Now this is the equation number 1, right? Now we have formed what is V1. Sorry, what is I1 with respect to V1 and V2. What is this one? This is nothing but Y parameter. Y parameter. This is Y11. This is Y12. Try to understand, right? That is what we have done here. And now what you do? You go for I2 to find. Maybe I will write it in a different way. KCL at node V2, right? This is the node, right? What are the current coming here? I2 is coming here, so it will be I2, right? I2 is in this direction, and see one more thing, I2 I1 is also in the same direction, right? So it will be plus 2 I1, that is also in the same direction, and that will be is equal to V2 by 10, and then plus the current if it is coming in this direction, so it will be V2 minus V1 divided by 10. Try to understand certain things. These kind of things I have already solved many problems. Please go through my previous lectures how to solve a nodal voltage analysis method to find current in the particular node, right? So if I want to get what is I2, then what it will be? So 0.1 V2 plus 0.1 V2 minus 0.1 V1, this value, and then minus 2 into what is I1 here? I1 is nothing but this value, right? So it will be 0.2 V1 minus 0.1 V2, right? This is the equation now. And if you need to simplify this equation to get what is the value of I2. So if you simplify this equation, what you will get? So I2 will be is equal to 0.1 V2. Maybe if you add these two, what you will get? So it will be 0.2 V2 and then minus 0.1 V1 and then minus 2 into 0.2. It will be 0.4 V1 and then minus of minus it becomes plus 2 into it will be 0.2 V2. Right now you see you have 2 V2s and 2 V1, right? So what you will get? So I2 will be is equal to minus 0.5 V1 and then plus 0.4 V2, right? Am I right? So this is the equation number 2 now. And now what I will do, I will bring the first expression 2 here so that it will be easy. This is first one, so I copy down and I will paste it out. So this is the first expression, right? So we don't need these kind of things, right? We don't need these kind of things, right? Now you see what is the first question. Let us see the first question. The open circuit voltage gain, we are considering it to be AV is equal to V2 by V1. When port 2 is open circuited, then this port is now open circuited, then obviously what happens? I2 becomes 0. I2 becomes 0 and we need to find what is V2 by V1. So what is the first condition? First condition, we need to find what is AV, that is the voltage gain V2 by V1 with respect to I2 equal to 0, right? I2 equal to 0. So if you make I2 is equal to 0 and the equation number 1 from equation number 1, what you will get? Sorry, not in 1, from 2. From equation number 2. So it becomes 0. So 0.4 V2 will be is equal to 0.5 V1, and finally V1 by V2, you bring this one to this side, this one to that side, so V1 by V2 will be is equal to V1 by V2, it will be 0.4 divided by 0.5, right? This is the voltage gain, and finally if you simplify this expression, then AV will be is equal to 1 minute. You see it is V2 by V1, right? So V2 by V1, so it will be inversed. So V2 by V1. So what you will get? You will get 0.5 divided by 0.4 and then this value will be 1.25. See, try to understand what is the value of AB now. We have found it to be 1.25. So this is the final answer for AB. And what is the second question they are asking you? Also very simple. The short circuit current gain AI is equal to minus I2 by I1. You need to find the value when port 2 is short circuited. If port 2 is short circuited, then what happens? Then V2 becomes 0. V2 becomes 0. So if V2 becomes 0 in both cases, what you will get? I2 will be is equal to minus 0.5 V1 and then I1 will be is equal to 0.2 V1, right? What they are asking you to find? They are asking you to find AI, that means minus I2 by I1 with respect to V2 is equal to 0. That is what they are asking you. So you divide, already there is a minus, so minus and minus it will be now plus, so AI will be is equal to 0.5 V1 divided by what is V2? It is 0.2 V1. So V1 will be cancelled out and finally if you are going for AI, if you divide these two, the value will be 2.5. So this is what we have found as current gain. This is the current gain. Current gain of the circuit and this is the voltage gain. See, try to understand these kind of things are all applications of a electronic circuit. If we have an electronic circuit or if we have an amplifier, you need to amplify voltage, amplify current and so many things you can easily find through the two-port networks. If you know exactly what is the two-port network network parameters, maybe Z or Y or H or ABCD, then you can apply so many things. These are all the very basic examples for amplifiers to find gains, voltage gain, current gain. See, we are just applying here, but while studying electronic devices and circuits in your third or fourth semester, you people will get a very good idea where to apply the two-port networks, right? So we will find other two things too. So now you see the third question. What is the third question? If 20 ohm resistor is connected across the port 2, which means I am going to connect a 20 ohms resistor across this port 2 now. So this value is 20 ohms. Now then what is the impedance seen from port 1? Then what is this question? So V1 by I1, which is nothing but it is impedance seen from port 1. And we need to find this value and see if this is V2, then you write the expression for V2. So start from this point, go in this way, the current is already going in this way. So it will be minus 20 into I2, right? That's all. We have just completed. And now what you do? You just substitute this in equation number 1. So I1, so what you will get? I1 will be is equal to 0.2 V1 minus 0.1 into minus 20 I2, right? Minus 20 I2. And if you further simplify this, I1 will be is equal to 0.2 V1. It will be now plus 2 into I2. Plus 2 into I2. And this is what I am getting from the equation number 1 here. So make this as equation number 3 maybe I can write like this, right? So now what you do, you just substitute this in this equation. So I2 will be is equal to minus 0.5 V1 and then plus 0.4 into what is V2 now? It is minus 20 into I2. So if you further simplify this, then I2 will be is equal to minus 0.5 V1 and then if you simplify this, it is minus 8 into I2, right? Then if you substitute this I2 in this particular expression, what you will get? So maybe this I2, what you can simplify from this here. So you can further simplify this one, right? So what you can do, you just bring this I2 to the other side, it will be 9I2 will be is equal to minus 0.5 V1. And if you further simplify this, I2 will be is equal to minus 0.5 minus 0.5 divided by 9 into V1. So if you simplify this, you will get minus 1 by 18 into V1. So now this is expression number 4. You just substitute this value here in this expression, what you will get? So I1 will be is equal to 0.2 V1 and then plus 2 into minus 1 by 18 V1. Right. So what you will get, I1 will be is equal to 0.2 V1 and then it will be now, this is 9 times, this will be 1 time, so it will be minus 1 by 9 V1. So if you further simplify this, what you will get? So I am getting it as now this expression as 4 by 45 V1. 4 by 45 V1. So what will be now V1 by I1? So if you bring this to this side, so V1 by I1 will be is equal to, this one will come here, then this one will be going, so it will be 45 divided by 4. And if you simplify this, and V1 by I1, I am getting it as 11.25 ohms. Now you see, this is the final expression for impedance seen from port number 1. This is the answer. We have found what is the impedance seen from port number 1. And we have another question too. We will see that. See, now we have taken to the other question, fourth question. If 20 ohm resistor is connected across port 1, which means we are just connecting a 20 ohms resistance across port 1. Then what happens to V1 now? So V1, so you are going in the same direction as current, so it will be minus 20 I1. That's all. Very simple, right? So now what you do? You just try to substitute this in the equation number 1 and 2. So first we try to substitute it in equation number 1. So then what is the question? They're asking what is the impedance seen from port 2, which means we need to find what is the impedance seen from port 2, that is V2 by V1. V2 by I2. So what you will get now, it is very simple. So from equation number, from equation number 2, not 2, it is 1. From equation number 1, what we will get? So I1 will be is equal to, so this is V1, right? So 0.2 into, what is V1 value? It is minus 20 into I1, minus 20 into I1 minus 0.1, it is V2. Right? If you further simplify this, it is now I1 will be is equal to minus 4 into I1 and minus 0.1 into V2. So you bring this to other side, it will be 5 I1 will be is equal to minus 0.1 V2, and then if you want to find what is I1, then it will be minus 1 by 50 V2. Minus, you just bring this one here and you just simplify this. So this will be equation number 3. I am taking this one, equation number 3. So now from equation number 2, you just substitute this value. That's all, very simple. Whatever V1 you have, you just substitute. So I2 will be is equal to minus 0.5 into minus 20 I1, then it will be plus 0.4 V2. And if you further simplify this, what you will get? So I2 will be is equal to, it is minus 0.5 into minus 20. So what I am getting, it is 10 I1 plus 0.4 V2. And then you substitute this I1 here. So I2 will be is equal to 10 into minus 1 by 50. And then this is 0.4 V2. And if you further simplify this, this is 5 times, this is nothing connected here. So what you will get, see this is minus 1 by, it is V2, right? So what you will get, so I2 will be is equal to, it is V2, right? So 1 by 50 V2. So it will be minus V2 by 5 and then plus 0.4 V2, right? This is the value now. So I will write here itself, somewhere else here. I will take this point. See, if you further simplify this, what you are getting, so I2 will be is equal to 1 divided by 5 V2, right? Now, if you further simplify this, V2 divided by I2 can be written as 5, right? You just bring this one here, 1 by 5. So, this is now the value of V2 by I2, right? Try to understand what is this one now. This is Z2, 5 ohms. This is the impedance seen from port 2. That is what we have found. This is 5 ohms, and impedance seen from port 1, it is 11.25 ohms, and that is the third question. And what is the first question? It is AV. How to find AV? That is the voltage gain of this particular circuit. It is 1.25. And what is the current gain? Current gain is 2.5. Right? That is what we have found from this particular question. Right? So you go through all these topics, and we will see in the next class with a different topic. Right? Thank you. You will see in the next class.